Good morning, friends. My name is Kumar, and you are watching with the Jain classes. So today's topic we are discussing about the fiber optics. So generally you are aware about the internet and internet speeds. What is internet and what is internet speeds? So internet is basically what? It is used for the data connections, and these data connections are done with the help of nowadays fiber optic cable. So if you deal with the fiber optic cable, what is fiber optic cable? So this video series we are recording in two parts. Today we are recording the first part, that is part 1, and second part is record tomorrow. So today first we are starting the part 1 of the Jain classes video lecture series by myself Kumar. So basically in your mind that introduction to the fiber optic cable or optical fiber. So it is technology in which signals are converted from electrical signal into the optical signal, transmitted through a thin glass fiber and reconvert into electrical signals. So optical fiber is used to transmit light signal over a long distance. A basic optical fiber system consists of a LED, laser diode, optical fiber cable and a semiconductor photodiode. So in this fiber optic cable or optical fiber, there are three parts are there. First one is core, inner side part is called core, which is made up of glass and plastic. So this core, there is cladding is there, and this cladding also made from glass and plastic, and on this thing buffer jackets are there, and these buffer jackets are made up from the dielectric material. So if you are showing the some very good fiber optic cable have the 5 things, that is core, cladding, buffer jacket. So instead of this 5 layer fiber optic cable, core, then buffer jacket is there, cladding, then buffer jacket is there, and outside that buffer jacket is also there. So there are 5 level systems are also available for the optical fiber for the communications. Next is the advantages of optical fiber over copper cable. So in our last centuries we are using the copper cable, but after the launching of 3G, 4G, 5G technology, we are moving forward for the optical fiber or fiber optic cable. So what is the advantages of copper cable for the fiber optic cable? So first advantages of use of optical fiber cable is it is cheaper. Fiber optic cable is cheaper than the copper cable. Why? Because fiber optic cable is made from the glass and plastic. So if you know the cost of copper cable is very high compared to this. Second, smaller in size, lighter in weight and flexible yet stronger. So fiber optic cable is what? Smaller in size compared to the copper cable, lighter in weight are very less, and flexible, not stronger, flexible but stronger. So this is the second advantages of fiber optic cable over copper cable. Third one is not hazardous. Fiber optic cables are not hazardous. Fourth one, immune to electromagnetic interference. and radio frequency interference, that is called EMI and RFI. Next is no crosstalk is going to happen with this. 6. Wider bandwidth. Bandwidth are very wider. 7. Low loss per unit length. So there is low loss per unit length. 8. Very high security. Laser fiber optic cables are very high security. 9. Longer lifespan and age of maintenance. So the lifetime of the fiber optic cable is around 20 years, whereas copper cable is only 7 years. Greater safety. Fiber optic cables are used for very high safety purposes. Next is very high corrosions. Next is the basic principle, that is called total internal reflection. So it occurs only if two conditions are satisfied. First, refractive index N1 of the core must always be greater than the refractive index of the cladding N2. So N1 core is always greater than N2 cladding. Second, the light must approach the wall with an angle of incident phi is greater than the critical angle phi c given by phi is always greater than phi c. So here we are using the Snell's law for the total internal reflection. So N1 sin phi c equal to N2 sin 90. So sin phi c equal to N2 by N1. So when phi equal to phi c, then sin phi c equal to N2 by N1. So critical angle phi c is defined as the value of the incident angle at which the angle of refraction is 90 degree. So phi is less than phi c. Refraction occurs rather than total internal reflection with the subsequent loss of the light ray into the cladding. Second, when the angle of incident phi is greater than phi c, so total internal reflections occur and reflected at the same angle to the normal. Third one, when phi equal to phi c, the refractive ray emerges parallel to the interference between the core and cladding, that is the angle of refraction is 90 degree. Next is Na and the acceptance angle. Acceptance angle of the fiber phi maximum is defined as the maximum value of the angle of incident at the entrance end of the fiber at which the angle of incident at the core cladding interface is equal to the critical angle of the core medium. So phi sin phi max is equal to square root of N1 square minus N2 square. N1 and N2 are the refractive index of the core and cladding. The core of the fiber has a refractive index N1 and is surrounded by a cladding of material with a lower refractive index N2. So order for a ray of light to propagate down the cable, it must strike the internal core cladding interface at an angle that is greater than the critical angle phi c. Snell's law to the external angle of the incident yield the field relations. So if we calculate all the things, so we are getting the phi in maximum, that is equal to sine inverse square root of n1 square minus n2 square. So phi n is called the acceptance angle or the acceptance cone half angle. So acceptance angle of the fiber is the maximum angle with which a little ray can enter into the fiber and still be totally internally reflected. B. A cone of light incident at the entrance end of the fiber will be guided through the fiber provided the semi-vertical angle of the core is less than or equal to phi in maximum. So the angle phi in maximum is unique only for a particular fiber. It differs from the fiber to fiber and depends on the material and the core diameter. Next is called the numerical aperture, that is called NA. It is a figure of merit that is used to describe the light gathering or light collecting ability of an optical fiber. Larger the magnitude of Na, the greater the amount of light accepted by the fiber from the external light source. So Na is equal to sine phi in maximum, where Na is equal to bracket, that is square root of n1 square minus n2 square. Na can be expressed in terms of normalized refractive index difference or relative refractive index difference delta. It is defined as the ratio of refractive index difference between core and cladding to the refractive index of the core. So delta is equal to n1 minus n2 divided by n1, where Na, that is called numerical aperture, is equal to n1 into bracket 2 delta. So for the all practical purposes, so numerical aperture Na is equal to n1 square root of 2 delta. Then today we are just stop here, because next time onwards, that is the second part, we are discuss about the types of the optical fiber. So thank you for watching videos. If you like the Jain classes, then you can subscribe my channel. If you do not like my Jain classes, you do not subscribe. Or if you have any query, you should write down in the description box which is below. So myself is, once more time I am introducing myself Shah Nirav Kumar. I am purchasing PhD from the Vadodara, one of the best university in Vadodara, in physics, and also run these Jain classes for the engineering students or engineering viewers only. These Jain classes are only for the engineering related fields viewers only, not anyone else, because this language is only recommended for the engineers who are studying engineering or who are have the background of engineering. That viewer only can understand this topic. Otherwise, because for this you have the some basic idea about the engineering. So these videos are only for the viewers or listeners who have the background of engineering, not anyone else. So once more again, thank you for watching this video. My name is Shah Nirav Kumar and I am thanking on the behalf of the Jain classes.